In this video, we are going to solve problems related to hypothesis test. The questions we will cover here, it's like writing the claim of a statistical test, state the null and alternative hypothesis, identify hypothesis test as the left tail, a right tail, identify and understand type 1 and type 2 errors that can happen, and identify hypothesis test as a left-right test. Okay, then we will learn to do interpretation of the test and make a decision also based on the test result. Okay, let's start first one. I already wrote down first one, so I didn't want to delete it. So first question: what are two decisions that you can make from performing hypothesis test? The result of hypothesis test is we're doing hypothesis test with one purpose: find out if we are accepting the claim or we reject the claim. In the language of statistics, we say we either fail to reject, that's a meaning we are accepting, and or we reject the null hypothesis. So one or another. Two decisions we are going to make. Okay, next one. Second question. Let me bring it up. Use given statement, meaning mu is greater than, let me see. Mu greater equals 624, that statement, to represent a claim. Write the complement and state which is null hypothesis and which is alternative hypothesis. Okay, when we have a greater, so if we have greater, then the complement is going to be less, right? If we have less, complement is going to be greater. So since we have mu is greater than equals 624, then complement it's going to be mu less than 624. That will be complement. Right? Now, how to figure out which one is null hypothesis, which one is alternative hypothesis? Null hypothesis always carry equal sign. Why? Because we always start with trusting and trust by verify, right? We always start with trusting, that is equal sign, and we test the equal sign. And that is null hypothesis that always going to carry our the testing case. So in this case, I can write down here null hypothesis. It's going to be mu is greater or equal 624, and alternative, which is going to be complement, it's going to be mu is less than 624. Next question. Question number 3. Use the given statement to represent a claim. Write the complement and state which is null hypothesis and which is alternative. So sigma, it's a population standard deviation. So if sigma is equal 12, then complement is going to be sigma is not equal 12. Right? Complement. Okay, now which one is null hypothesis, which one is alternative? Remember we said that a null hypothesis always carries equal sign. Therefore, null hypothesis is going to be sigma equal 12. And accordingly, alternative, I put alpha or A, doesn't matter, is not equal 12. Okay, question number 4. Use the given statement to represent a claim. Write a complement and state which one is null hypothesis and which is alternative one. So we have P is a proportion. To remind you, proportion is less than 0.33. So complement is going to be P greater or equal 0.33, right? That's a complement. Accordingly, so null hypothesis will be, which one has equal sign? Greater or equal, right? P is going to be greater or equal 0.33 proportion, and alternative one is going to be proportion is less than 0.33. Okay, next question, number 5. A null and alternative hypothesis are given. Determine whether the hypothesis test is left-handed, right-tailed, left-tailed, right-tailed, and or two-tailed. Okay, the tail we identify based on alternative hypothesis, right? So in our case, alternative hypothesis, it says greater, which means it's going to be, so greater is, it's going to the left, to the right. Look here. If it goes to the right, then it's a right tail, right? If it goes to the left, meaning less, then it's a left tail. So let's say sigma is greater than right one, and sigma less than, it's going to be left one. And two tail, it's limited by 2, it's going to be sigma equal. Okay, so we have sigma greater, which means we are going to have right tail. One more time, you identify this, if test is right at which tailed, you look at alternative hypothesis. If it's greater, then right tail. Less than, then it's left tail. Equal, then two tails. Next one. A null hypothesis and alternative hypothesis are given. Determine whether hypothesis test left tail, right tail, two tails. Well, obviously equal, not equal. Remember here? So it's a two tail. Two-tailed test. Next question. For the statement below, write the claim as mathematical statement. State a null and alternative hypothesis and identify which represent the claim. So what do we have? A laptop manufacturer claims that mean life of battery for a certain model of laptop is less than. So which means average life, mean life, which means average. It's mu is, that means is less than 9 hours. Mu is less than 9 hours. It doesn't say less or. So when only less than hours, it's gonna be our alternative hypothesis, right? So null hypothesis and alternative hypothesis. So if less than, it's our alternative because it doesn't carry equal sign. Then null, it's going to be greater equal, right? 9 hours. Sometimes they don't put greater, they just put now is equal. That's it. Because if you have less than, then it's clear that alternative going to be greater equal. Question number 8. For the statement below, write the claim as a mathematical statement. Okay. An amusement park claims that the mean daily attendance at the park is at most. When it says at most, that's mean 18,000 or less, right? When it says at most, that's mean 180,000 or less, which means average mean attendance, here it is, keyword mean attendance, that's mean it's going to be mu, that is less equal 18,000. Okay? And therefore, mathematical statement of the claim is going to be, since we have equal sign, it's going to be null hypothesis. And accordingly, it's going to be alternative. Question number 9. For statement below, write the claim as mathematical statement. Okay, a company claims that its brands of paint have a mean, so we are dealing with average, drying time of less than 90 minutes. So mu is going to be less than 90 minutes. Accordingly, null hypothesis and alternative. In this case, we have alternative because equal sign is missing. And mu is greater equal 90 minutes. One thing I would tell you, I would like to tell you that you don't necessarily have to have precisely less. Since I have less, you might have greater than or greater equal. So you just have to learn in which case what and put in there. But in my examples, will give you idea how to answer the question. Okay. One second, I think I missed something. Yeah, I think I didn't answer a couple of more questions there. Let me see. Yeah, let me go back from number 7. I'm sorry, I didn't pay attention. Let me go back to number 7. For statement below, write the claim. Okay, so we put down there the hypothesis test claim. Okay, we have mu is greater or equal 9, and alternative is going to be less than 9. So now we need to identify which one is our claim. The thing is, claim can be either null hypothesis or alternative hypothesis, because whatever case the word problem is giving, that one is going to be your claim. Here we have less than, that's mean alternative. This alternative is the claim. Okay, it's going to be your claim. Next, for number 8, let's finish for number 8 also the case. What do we have? The claim here says at most $18,000. At most is this one, null hypothesis, which means this time it's going to be, the claim is null hypothesis. Like I said, you have to follow what the word problem says, and that is going to be your claim. Next, for the statement below, okay, we already have it. Mu, for question number 9, greater equal 90, and alternative less than 90. That means it's going to be less than 90. It's the one going to be claim. Okay. Question number 10. Let's finally move to our problem. Number 10, we stopped by. So we have for statement, so same thing. According to recent survey, 30% of college students own a credit card. So if it's on the credit card, that means we are going to deal with proportion, right? So, in theory of college student own, meaning equal, right? It's own, they have it. So its claim is going to be P is equal 30%, meaning 0.3. And accordingly, because it's equal, then our null hypothesis going to be P is equal 0.3. And alternative, accordingly, it's going to be P is not equal 0.3. Since it's given student own credit card, survey 30%, then this one, the null hypothesis, is our claim. Question number, no, hold on. Yeah, we have claim. Number 11. A local chess club claims that the length of time to play a game has standard deviation of more than 10 minutes. Okay? Oh, standard deviation of 10 minutes or less. Okay? Less equal, right? That means less equals for standard deviation. So, type 1 error. We need to identify, right? Statement describing type 1 or type 2. Type 1 error occur when null hypothesis is rejected when it is true. Null hypothesis is rejected when it is true. Okay. Next. Type 2 error occurs if the null hypothesis is not rejected when it's false. Okay, so what do we have in this case? What we can say? So, we can say that a type 1 error will occur if the actual standard deviation on the length of time to play a game is greater than deviation 10 minutes or less. Yeah, it's greater than type 1. So let me write down here. If greater than or equal, no, equal sign we have there. So sigma if greater than 10. Okay? But you reject the null hypothesis. Okay? So which means, it's going to be null hypothesis, it's going to be sigma less equal 10. Alternative is going to be greater than 10. Okay. For type 2 error, this is type 1 error. I guess it will be easier to write down. Type 2. For type 2 error, we say that null hypothesis is less equal ten, but no, we are doing false, right? We need to do false, opposite. Okay, is greater than, we are telling the false. The truth is it's less equal, but we claim that it's greater than. And alternative, and but we fail to reject, which means sigma is going to be less equal 10. Okay. All right, moving to question number 12. Describe type 1 and type 2 errors for hypothesis test in the indicated claim. A culinary school publicized that at least 10% of applicants become full-time students. Okay, so a type 1 error will occur when actual proportion of applicants, it's going to be at least 10%, but we reject, so null hypothesis. And null hypothesis in this case for type 1 error, it's going to be proportion is greater or equal 0.1. Okay, so one more time, type error will occur if the actual proportion of the applicants would be at least 10%, right? But we reject it, which means null is going to be greater than, because realistically it's less, but we accept as a greater than. Okay, this is type 1 error. Type 2 error, that means that will occur when actual proportion of applicants is less than 10%, but we failed to reject, which means null hypothesis here, it's going to be greater or equal 0.1. One more time, the type error will occur when the actual proportion of applicants is less than 10%, but we fail to reject null hypothesis, which means proportion is greater or equal 1, 0.1. Question number 13. Identify type 1 and type 2 hypotheses. Okay, what do we have? The percentage of students who own cars less than 35%. Okay, so type 1 error. So for to identify type 1 error, we have to say that we reject null hypothesis, that the percentage of students that own the car is greater than or equal 35%. Okay, when it's true. Okay, and type 2 error, we fail to reject null hypothesis. Keep in mind that all decisions about errors we are making related to null hypothesis. So we fail to reject null hypothesis that the percentage of students who own a car is greater than 35%. Hold on, it's only Yeah, greater or equal 35% when it's actually false. Here we put when it is true. All right. Question number 14. A security expert claims that exactly 15% of all the homeowners have a home security alarm. Okay? We need to state null hypothesis, alternative hypothesis in words and in symbols. Then determine whether hypothesis test for claim is left-handed, right-handed, or two-tailed. Okay, let's do that. So, in our case, it's going to be the null hypothesis that is expressed in words. The proportion of all homeowners, this is for null hypothesis. The proportion for all homeowners who own a home in the security alarm is 0.14. Okay? The null hypothesis is expressed symbolically as P proportion is equal 0.14. Every time when we have percentage, we are dealing with proportion. Okay, now let's do the same thing about alternative hypothesis. So for alternative hypothesis, we are saying the alternative hypothesis expressed in words the following way. The proportion, so I'm putting here dashes and because it's the same word, right? Wording for all homeowners who owns home and alarm, okay, is not equal 0.14. Okay? So therefore, alternative is equal P is not equal 0.14. Question number 15. So which of the following is not a true statement about error in hypothesis testing? Okay. We know one thing that is for sure. A type 1 error is making the mistake that rejecting null hypothesis when it's actually false. Okay. Next one. Number 16. Determine whether the claim below represent null hypothesis or alternative hypothesis. If hypothesis test is performed, how should you interpret decision that reject null hypothesis or fail to reject null hypothesis? Okay, we have a government agency claims that at least 73% of full-time workers earn less than $543 per week. Okay, so does this claim represent null hypothesis or alternative hypothesis? It says at least, that means it's greater or, right? So since the claim contains a statement of equality, right? Because it says at least, that's mean greater or equal 0.73, right? So then it represents null hypothesis. Right? Now, how should you interpret the decision that rejects the null hypothesis? We are going to interpret the following way. There is enough evidence to reject the claim that at least 73% of full-time workers earn more than $543 per week. Okay? Enough evidence. Okay, enough evidence to reject. And B, how would you interpret decision for that reject null hypothesis? Okay, we would say there is not enough evidence to reject the claim that at least 73% of full-time workers earn more than $543 per week. Question number 17. So what do we have? Medical research team is investigating the mean cost of 30-day supply of certain heart medication. A pharmaceutical company thinks that mean cost is more than $59. You want to support this claim. How would you write null hypothesis and alternative hypothesis? If I want to support this claim, then I would write down mu is less equal 59, right? Oh, more than 59, okay? That means alternative, yeah, we are good. There is no equal sign, so alternative here, it's going to be more than 59. Alternative going to be greater than 59. Okay? Number 18. A refrigerator manufacturer claims that the mean life of its competitors' refrigerators is less than 12 years. Okay, less than, that's already feels like it's an alternative, right? Mean life, because it's mean, so I put mu is less than 12. You are asked to perform hypothesis test, okay? How would you write a null hypothesis if you represent manufacturer and want support claim? Okay, for A, it's going to be null hypothesis, the alternative is less than 12, and null is going to be accordingly mu is greater equal 12. Let's now do B. How would you write null and alternative hypothesis if you represent a competitor and want to reject the claim? If I want to reject the claim, so it's going to be all opposite, right? So which means the alternative one, I'm going to write down mu is greater than 12, and null is going to be less equal than 12. That's all. You're doing opposite operation. Okay, question number 19. Why can decreasing the probability of type 1 error cause an increase of probability of type 2 error? Very good question. Because that's when we are talking type 1 error or type 2 error, it depends on it's working with alpha. Remember, this is our error, correct? This is our alpha, the area, right? Okay, that's from elementary statistics. So decreasing alpha, it decreases probability of rejecting null hypothesis. Let me see. Alpha decreasing, putting this way, hence that means probability of rejection decreasing. That means you have less errors, so probability of the going down also. The probability of rejecting decreasing also. Probability of rejection decreasing. Keyword for rejection of null hypothesis. Let me put here null hypothesis also decreasing. This increases the probability of the complement, right? Because event plus complement, it's going to be 100% or 1. So if this goes down, then this goes up, right? If you have 40, 60, and this one become 70, it's going to become 30, right? It's opposite. It's like scale. If total is 1 increase, the other one will decrease. Okay? So this increase the probability of the complement not rejecting the null hypothesis, which could increase probability of failing to reject the null hypothesis, okay, when it is false. And that's a type 2 error. Okay, number 20. Explain why a level of significance alpha is equal 0 is not used. Because when alpha is equal 0, the null hypothesis cannot be rejected, right? Because we put equal sign and it's 0. Then null hypothesis can be rejected. That's why. And there is no hypothesis test this way. And the last question, a null hypothesis is rejected with a level of significance 0.05. Is it also rejected with level of significance 0.1? Explain. Yes, it will. Because the claim would be rejected because p-value would be less than 0.1. Yes, because p-value would be less than alpha, which is less than 0.1. Yeah, p-value is 0.05 and alpha is 0.01. Therefore, we would reject. Okay, I'm done. Hopefully this will help. And I'll see you in the next video.